Hey everybody, what's happening? Well, today we're going to take a look at how to find the empirical formula of a compound. Now, the empirical formula is the lowest ratio of atoms for a compound. So example here, we've got CH2 and CH3. Notice we can't break those compounds down into anything that's more simple than that. Now, in contrast to that, we've got the molecular formula, and this is just a multiple of the empirical formula. And what you can see here is that if we have CH2, if we multiply that molecule by 2, we get C2H4. It's the same ratio of carbon to hydrogen, it's just we have more of them. All right, and you can see we also have another one here where we have C5H10, and that's just times 5 CH2. All right, so let's check this one last one out. We have CH3 here, and a multiple or a molecular formula of that would be C2H6. It's still got the same ratio of 1 carbon to 3 hydrogens, but we just have twice as many. Now, you may also notice that the molar masses are multiples of as well, and this is something we can tell when you're asked for the empirical formula and then you're given a molecular formula. You're just going to divide the molecular formula by the empirical formula to determine how many times you had to multiply it by. And if you look at CH2, it's 14 grams per mole, C2H4 is 28 grams, and C5H10 is 70 grams. They're all multiples of the first one. All right, so let's go down and check out what a couple questions here. And so we've got a new barium-nitrogen compound was discovered. When the sample was analyzed, it was found to be 76.5% barium. What is the empirical formula? So first off, we need to determine what the other part was for nitrogen. And we just go 100 minus 76.5, and we get 23.5% was nitrogen. All right. So what we have right now is we have 76.5% of barium, and we have some nitrogen, and it was 23.5%. The key when you're finding empirical formula is we have to assume that we have 100 grams of the compound. This makes our lives a lot easier because then all we do is go straight across, and if we have 76.5% of 100 grams is just 76.5 grams. And we do the same thing with nitrogen, and we have 23.5 grams. All right, so we've got percent to mass, and I'm going through the steps here. So we've got percent to mass, mass to moles, and then we're going to divide by small. All right, so we've got percent to mass, and now we're going to find out what the mass is of 1 mole of each one of our elements. It turns out that our molar mass of barium is 137.3 grams, and the molar mass of nitrogen is 14 grams. So we determine how many moles we have, we cancel out our grams, and we find out that we have 0.5571 moles of barium, and then we go 23.5 divided by 14, and we have 1.678 moles of nitrogen. Now, we've gone from percent to mass. We assumed we had 100 grams, and now we're going from mass to moles. Now, once we get to moles, we're going to divide by small. So we're going to divide by the smallest number of moles we have, 0.5571. We do that for each element. And what we do is we get our ratio now. We have 1 barium, and we go 1.678 divided by 0.557, and we get 3. So what this does is this gives us our empirical formula, and we get Ba, we have one of them, and N3. All right, let's try another one. There are 2 common oxides of sulfur. One contains 32 grams of sulfur for each 32 grams of oxygen. The other contains 32 grams of sulfur for every 48 grams of oxygen. Find the empirical formula for each. All right, so let's do the first one. We have sulfur, and we have 32 grams. And we have oxygen, and we also have 32 grams. All right, so what we need to do is we need to get this, find the percent composition, and then we're going to get it into a mass, again, out of 100. So what we're going to do is we have a total of 64 grams altogether. And I did that by adding 32 plus 32. And I get 0.5, and I get 0.5. So what that says to me is this is my percentage, it's 50%. I'm not going to multiply it by 100. But what I do get is I get 50 grams. So I assumed I had 100 grams total. And because there's half and half, I have 50 grams of sulfur and 50 grams of oxygen. Now I'm going to get my molar mass, and I've got 1 mole on top, and my molar mass of S is 32.1. And I do the same for oxygen, and I have 1 mole on top, and I have 16 grams per mole. Now I'm going to go 50 divided by 32.1, and I get 1.557 moles. And over here I go 50 divided by 16, and I get 3.125 moles. So I've gone from my mass to a percent, and now I'm going to find my grams, assuming 100 grams. Then I go to moles, and now I'm going to divide by small. So divide by 1.557, divide by 1.557, and I get 1 over, and I get 2. So I have SO2. My other compound that I said I had was I had an S and I had an O, and I had 32 grams of sulfur and I had 48 grams of oxygen. So what I did was I added those up and I found that my total was 80 grams. And now I find that I get a percentage here, and it's 0.4, and over here I get 0.6. So if I had 100 grams of this compound, I would have 40 grams. And if I had 100 grams of this compound again, I'd have 60 grams of oxygen. Now I'm going to go from mass to moles and then divide by small. And I put grams on the bottom and 1 mole on top. And my molar mass of sulfur is 32.1. My molar mass of oxygen is 16 grams. I go 40 divided by 32.1 and I get 1.25. And over here I go 60 divided by 16 and I get 3.75. So I divide by small and I get 1 and 3. So my new ratio is SO3. All right, have a good rest of the day.